Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our today's video, we are going to check out some of the advantages and disadvantages of the merge sort. So let's get started. Before we get started with the advantages and disadvantages, I want to quickly have a recap at how this merge sort basically works. If you remember that merge sort works in three ways: divide, conquer, and merge. Basically, we split the array in half. Then we make a recursive call, we merge the results and repeat until it reaches the bottom of the array tree. Remember that? So with that in mind, let's talk about the advantages. So the very first is that it is a stable algorithm. What we mean by the stable algorithm? Remember that? Stable algorithm means we preserves the order of equal elements in the input array, right? We preserves the order of equal element in the input array. That is, for example, you have 2, 7, 8, 2. This is your first 2, this is your second 2. So when you will sort, you will get something like this, but you will get first 2, then second 2. So that order is maintained. That is called a stable algorithm. You might have also heard stable and in place, right? Many algorithms are in place algorithm because of the additional space or something, right? So remember this. Merge sort is a stable algorithm, right? Second, it is an efficient algorithm. If I talk about the efficiency, okay, why I'm saying it's an efficient algorithm? Because merge sort has guaranteed of what time complexity n log n for all three cases. Remember, it has n log n in worst case, best case, and the average case. So because of its time complexity n log n, this is very efficient in case you use a larger data sets also, because this is going to remain same. I have told you, right? It remains same in three conditions. So it helps in the large data set. So it maintain the same n log n order in the large data set as well. Then third advantage is works well with unordered data. All right, works well with unordered data. What we mean by this unordered data means, see, it performs very well. Very well in the sense it performs same actually, because I have talked just now. Whether you take best, you take average, or you case, the worst case, right? In any of the case, right? And regardless of how unorganized the data is, right? It's gonna work same, right? So it works well with large data set. It works well with unorganized data set. It works same with the organized data sets, same, right? Then it also useful for what you called as linked list, okay? Because it does not rely on the random access to data, okay? For randomly you cannot do that, right? There are a lot of algorithms which do, right? And it can also do a external sorting. That is very important. Why external sorting is important? Where you have a restriction of the memory. So it just take that much chunk into it, sort it and use it. That is why we say, when we talk about external sorting, right, we talks about efficiently handling the disk-based storage, right? Because see what we do, for example, there are two chunks. Let me just show you this. Now I have my disk for these two only, these two things. So I'll just take these, I will sort them, okay, A and B. I will take it into, when these are clear, I will take these two. So I have got this C and D. And then when I have a space, I will take A, B, C, D all together. That is why it is efficiently handles the disk-based storage. So these are the some of the advantages of this. Now let's talk about the disadvantages. Disadvantages. So I talk about disadvantages is like if you have a smaller list, it becomes a problem, right? So for a bigger list, it's going to take a same, right? So if it is smaller list, it becomes slower because it will take n log n, right? But you have other algorithms which can quickly sort the smaller arrays, right? So the first point is slower for smaller list. Okay, smaller for smaller list. That is, it can be slower for smaller list that other algorithms like you have quicksort, right? Then second is you use temporary array, right? That is B of k. That is the extra space you need, right? So it requires additional memory. That is O of n, correct? That is proportional to the size of the array you have, right? Then third is, see, you have easy algorithm than merge sort also, right? So it is complex to implement. I feel so that is not much complex, but I write complex to implement considering the other algorithms available, right? So these are some of the disadvantages of the merge sort, correct? So if I need to, summarize, this merge sort is a divide and conquer algorithm which is very efficient for sorting the large data set, sorting the unorganized organized data set. However, it can be slower for the smaller list and might require or might it requires additional memory proportional to the size of array we have. So that is what the advantages and disadvantages of merge sort. In our next video, we are going to take about some of the real world applications of the merge sort algorithm. If you like this video, please do like, share, and subscribe. Thank you.